Assalamualaikum warahmatullahi wabarakatuh. Hey, my name is Bivany Josania, NIM 190290012. I'm from Mathematics Education Class B, Padang State University. Now, I'm going to present about system of linear equations in two variables. For the first, system of linear equations in two variables. Recall that an equation of the form ax plus by equals c is a linear equation in two variables. A solution of a linear equation in two variables is an ordered pair xy that makes the equation a true statement. For example, -2, 3 is a solution of the equation 2x plus 3y equals 5. Why? Because 2 times -2 plus 3 times 3 equals 5. The second is linear equation system. What is a system of equations? A system of equations is two or more equations considered together. The following system of equations is a linear system of equations in two variables. For example, like this. 2x plus 3y equals 4, and then 3x minus 2y equals -7. A solution of a system of equations is an ordered pair, that is a solution of both equations. The next, I will explain to you about the completion of the linear equation system. There is two solutions for solving a system of equations. For the first, substitution method for solving a system of equations, and then elimination method for solving a system of equations. Equation 1. Solve a system of equation by the substitution method. There is two equations. The first 3x minus 5y equals 7, and then y equals 2x. The solution of y equals 2x are the ordered pairs x to x. For the system of equation to have a solutions, the ordered pairs of the form x to x also must be solution of equation 1. To determine whether the ordered pairs are solution of equation x to x are solution of equation 1, substitute x to x into equation 1 and solve for x. Think of this as substituting 2x for y. Equation 1 substitute for y. Equation 1 is 3x minus 5y equals 7, and then 2x substitute for equation 1. 3x minus 5 times 2x equals 7, and then 3x minus 10x equals 7, minus 7x equals 7, and the result is x equals -1. Equation 2. Substitute -2 for in equation 2. Equation 2 is x equals 2x, and then substitute -1 to equation 2. Y equals 2x, and then y equals 2 times -1 equals -2. The only solution of the system of equations is -1 and -2. You can check your work by showing that -1 and -2 satisfy both equations in the original system. Example 2. Identify an inconsistent system of equations. What is an inconsistent system of equations? A system of equations is called an inconsistent system if there is no solution of equations. For example, solve x minus 3y equals 6 and then 2x plus 6y equals minus 18. Solve equation 1 for y. X minus 3y equals 6 and then y equals minus 1 over 3x plus 2. The solution of x minus 1 over 3 plus 2 are the ordered pairs x minus 1 over 3 plus 2. For the system of equation to have a solution, ordered pairs of this form must also be solution of equation 2. Equation 2 is 2x plus 6y equals minus 18. To determine whether the ordered pairs are solution of equation 2, substitute into equation 2. 2x plus 6y equals minus 18, and then equation 1 substitute to equation 2. 2x plus 6 times minus 1 over 3x plus 2 in bracket equals minus 18. 2x minus 2x plus 12 equals minus 18. 12 equals minus 18. The false statement 12 equals minus 18 means that no ordered pair that is a solution of equation 1 is also solution of equation 2. The equations have no ordered pair solutions in common. Thus, the system of equations has no solution. This is an inconsistent system of equations because there is no solutions of equations. Example 3. Identify a dependent system of equations. Inconsistent systems represent the parallel lines, while dependent system represent in the same line. Solve 8x minus 4y equals 16 and then 2x minus y equals 4. Solve equation 2 for y. 2x minus y equals 4 and then y equals 2x minus 4. The solution of y equals 2x minus 4 are the ordered pairs x, 2x minus 4. For the system of equation to have a solution, ordered pairs of the form x, 2x minus 4 also must be solution of equation 1. Equation 1 is 8x minus 4y equals 16. To determine whether the ordered pairs x, 2x minus 4 are solution of equation 1, substitute x, 2x minus 4 into equation 1 and solve for x. 8x minus 4y equals 16. And then substitute 8x minus 4 times 2x minus 4 in bracket equals 16. 8x minus 8x plus 16 equals 16. 16 equals 16. And this is a dependent system because represent in the same line. The true statement 16 equals 16 means that the ordered pair x, 2x minus 4 that are solution of equation 2 are solution of equation 1. Because x can be replaced by any real number c, the solution of the system of equation are all ordered pairs of the form c 2c minus 4. This is a dependent system of equations. Last time, I explained to you about solving a system of equation by the substitution method. Now, I will explain to you solving a system of equations by the elimination method. For example, like this. Solve 3x plus 4y equals 10, and then 2x plus 5y equals minus 1. Use the operation that produce equivalent equation to eliminate a variable from one of the equation. We will eliminate x from equation 2 by multiplying each equation by a difference constant, so as to create a new system of equations in which the coefficient of x are additive inverse. Equation 1 times 2 and the equation 2 times minus 3. 6x minus 8y equals 20, and then negative 6x minus 15y equals minus 3. So, minus 23 y equals 23, y equals minus 1. Solve equation 1 for x by substituting for y. Y equals minus 1 and y substitute to equation 1. 3x plus 4y equals 10, and then 3x plus 4 times minus 1 equals 10. 3x equals 6, and then x equals 2. The solution of the system of equations is 2 and minus 1. The method just described is called the elimination method for solving a system of equations, because it involves eliminating a variable from one of the equations. Example 5. Solve a dependent system of equations. Last time, I have explained to you about the dependent system. Dependent system represent in the same line. For example, solve x plus 2y equals 2, and then 3x minus 6y equals 6. The solution is eliminate by 1 over 3 multiplying equation 2 by minus, and then adding the result to equation 1. X plus 2y equals 2, and then the equation 2 multiplying by 1 over 3 minus x plus 2y equals minus 2, and then 0 equals 0. 0 equals 0. X plus 2y equals 2. 0 equals 0. Because 0 equals 0, the equation is an identity, an ordered pair that is a solution of 0 equals 0. Equation 1 is also a solution of equation 2. Thus, the solution are the solution of x plus 2y equals 2. Solving for y, we find that y equals minus a half x minus 1 because x can be replaced by any real numbers c. The solution of the system of equation are the ordered pairs c minus a half c minus 1. And then I will explain to you about the operation that produce equivalent system of equations. There is 3. The first, interchange any two equations and then replace an equation with a non-zero constant multiple of that equations, and the last, replace an equation with the sum of that equation and a non-zero constant multiple of another equations in the system. Because the order in which the equations are written does not affect the system of equations, interchanging the equations does not affect its solution. The second operation restates the property that multiplying each side of an equation by the same non-zero constants does not change the solution of the equation. The third operation can be illustrated as follows. Consider the system of equations. It's enough of my presentations. I can conclude that there is two solutions for solving a system of equations. For the first, substitution method for solving a system of equations, and then elimination method for solving a system of equations. If there is my fault, I apologize for the size. Thank you very much for your great attention. Assalamualaikum warahmatullahi wabarakatuh.